So on the last topic, we talked about how you have the base and we have the power of some exponent that will give me some number, right? And we also talked about how logs are inverses of exponents. So essentially, a log, just as we have a to the x power, where a is equal to the base, and x is the power, x equals the power, and together a to the x equals some number, right? Where it's any number in the number system you can think of. I don't care what it is. Think of any number. Say it out loud. It can be whatever. It can be some crazy long number. It's still just a number. Well, in terms of this, if I have log a of the number, I'm going to get x. So essentially what happens is that a becomes the base of the logarithm. So a is the base of the logarithm. Now, one way I like to think about bases, okay, and it comes up as a brief topic in discrete mathematics and a lot more so in computer science when you're dealing with machine learning and C++ programming. A numerical base is basically a list of numbers in which you're going to use to operate with. So numerical base is the set of numbers in which you manipulate numerically with operations. So it's the whole set of existential numbers that can be utilized for numerical manipulation via operations. And I know I forgot a C. So one way to think about it is, how many fingers do you have on your hand? Well, you've got 10 fingers. So the base 10, the list of numbers, is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That is 10 numbers. And then you immediately start putting on, well, you got 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So the numerical base is the whole set of existential numbers that can be utilized for numerical manipulation and counting principles. Now, a lot of teachers, when they teach logarithms, they don't really talk about this, but the base is basically the amount of numbers you can count with. Okay, so if I say, hey, you're dealing with a log base 2, and I know that when you do that, you're going to get some number 32. Well, I know that's 5. So essentially, what some teachers do to help people out to understand this a little bit better is, instead of doing this and saying, hey, what if you just had base 2 and you only had zeros and ones you can manipulate? Well, now you've got 1, 0, and you got a 1, 1. You've got 0, 1, 0, and 0, 1, 1. You've got 1, 0, 1, 0, and 0, 0, 1, 1. And if you start doing that, you get some crazy things. For instance, 0 plus 1 is definitely equal to 1. But 1 plus 1 does not equal 2. 2 doesn't exist. You only have zeros and ones. So 1 plus 1 would be 1 0. And 1 0 is 2. I know, it's crazy. So, most teachers like to prevent talking about that because it's just nasty looking. So what we do is we say, hey, log base answer equals power. And basically, it doesn't matter. All you're going to do is, like, you're going to have some a to the x equals a number. Hey, I can rewrite that as log base a of that number equals x. So basically, drop this down, and then move this over here, and then move the number over here. And then write log out in front. And if you write log out in front, you're golden. So if I say, hey, express 2 to the 16th power in exponential form. Well, whatever 2 to the 16th power is, which is a number, I don't really know what it is off the top of my head. I don't really care at the moment. But if you want to figure that out, you can understand that it's 2 squared times 2 squared times yada 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 yada. 2 times 2 times 2 times 2 times 2 times 2 times 2. And you can figure it out. If you do it 16 times, you'll get a number, right? Well, I'm going to drop it down and I'm going to say, hey, log base 2 of that number, right, whatever that number equaled out to be, equals 16. Isn't that pretty cool? So I can rewrite them in terms of each other, and that's because they are inversely related. So that's what we call the process of logarithmic expansion. I like the sound of that word, logarithmic expansion. It's where you expand the exponential statement and rewrite it in terms of a logarithm. Really cool. Well, I hope you enjoyed the lesson. The next topic we're going to talk about is learning how to graph these problems.